Right, so we're going to talk about general angles today. We have a reference angle. The reference angle is a positive, acute, remember acute is less than 90, angle with one side on the x-axis. Really important to remember one side's on the x-axis. That's critical. And I'm going to give you a bunch of angles, and you're going to find its reference angle. Okay? So you're going to find which angle is considered to be its reference. Start with the first one. If I give you 135 degrees, in your first step, we kind of just did this as a warm-up, you're going to figure out where it falls. Okay? So if you count, remember this to be 0 degrees, 90, this is 180, right? So 135 is in quadrant 2. Then your next step is to actually call the angle. In other words, if you start here and you travel all the way to here, we would call this 135 degrees. Does that make sense? Okay, that's going to help you visually see this better. Now, a reference angle is considered to be an acute, okay, an acute angle with the x-axis. So a little angle that touches the x-axis. So that would be right here. Because here's my angle, and here's an angle that touches the x-axis that shares that part.
So it's the other part.
Kind of. It's the other part. But it always has to touch the x-axis. So you'll see they're all a little different. My question to you, they're going to ask you, how big is it? What's the measure? So if I'm at 135 at this line, which is the reason we marked it, and to here is 180, how would I find out how much that is? What would I need to do? Good, just subtract. 180 minus 135. So you're going to call that your reference angle, and we just read me, REF angle is 45 degrees. And don't forget your degree mark. 180 minus 35. Okay, now.
You have to write it like that,
Guys.
reference angle.
Okay, say it again.
Do we have to write it like that, reference angle?
Yes, good question. The answer's written as reference angle is 45. Alright, now let's go to number 2. This time I'm going to tell you a 200 degree angle, and I'm asking for what is its reference angle. You drew a picture, and you're at 200 degrees. Okay, make your rounds. 0, 90, this is 180, so 200 is in quadrant 3. Okay, and then mark it. From 0, because it's going to matter. Later we're going to go negative, so you go the other way. So it makes a difference. So 0 to here, you can label it as 200 degrees. But then you're going to have to decide where's your reference angle at. What was the hint I gave you? It's an acute angle, and it always touches the x-axis. So put your finger on your guess where you think where you're going to shade. Just guess. Now then, think about it. If this is part of my angle, okay, and it has to touch the x-axis, it's this angle here. Okay? Now, how are you going to find out how big that is? Use some common sense. If I'm at 180 here, and to get down to here I'm at 200, what is the shaded angle? How past did I go? 20. Okay, if you aren't sure, then you can say, okay, 200 minus your 180. So your reference angle is 20 degrees. Number 3. How about 310? Try that 90, 180, 270. I'm all the way in quadrant 4 this time. Mark it. From 0 all the way to where I stopped is considered 310 degrees. Okay, that's kind of what we're learning. It's asking, how do I know where to shake? Okay, let me think what I told you. Your angle you shake has to touch the x-axis. So this is your x-axis, and it has to be acute, right? And your terminal side needs to be part of the angle. So this right here has to be part of the angle and has to be acute. So the only spot to touch would be here. Make sense? Okay. And then, but on this particular one, if I looped all the way around, I'd be at 360. So I stopped here at 310, and from here to the end, or for one full loop, is 360. So what do you think that the reference angle is? 360 minus 310. So the reference angle is 50. Number 4.
What did you use 1570?
Pardon?
You said.
It's an acute angle.
Right.
50.
You said 350 and I didn't see what you
The reference angle is 50. Now let's try 155. Zero, 90, and 180. 155 falls in quadrant 2. The reference angle has to be acute and touch the x-axis. So this is my reference angle. I traveled to 155, so from 155 to 180 is how much you need. Right, so 180 minus 155, your reference angle is 25 degrees. We have 2 more. One is pretty easy. And number 6 is a little different. Try those 2. What is the reference angle of a 40-degree angle? 40 degrees. You didn't even have to do any math, right? It wants the terminal side to be part of your angle, and it has to have part of the x-axis. So it's just this mark right here. So your reference angle of 40 is 40. X-axis. It has to touch the x-axis. So it's not this side because that's touching the y-axis. You could do. Now, 480. 480 is greater than 360. So it is going to make an entire loop plus more, right? So count with me for a second and let's try this. 0, 90, 180, 270, and all the way around makes how much? 360. Now, 360 and 90 more. Well, 360 and 100 more is 460. It's 10 less, so it's 450. 450 and 100 more is 550, but we only need 90, so 540. Where does 480 fall? Correct, right here. Okay, but when you get ready to label this, okay, when you get ready to label it, you're going to watch for a second. We started at 0. We made one complete loop, didn't we? There's my loop. And then I got to keep on going all the way to there to show that that is 480. Now touch where you think the reference angle is. It has to be part of the x-axis. Touch it. Did you get this part right here? okay? Which is the distance from 480 to 540. Right, so do 540 minus 480 and you get 60 degrees. Wait, I said one more, but I forgot negatives. Sorry. Try number 7. This time, negative 125. So remember what you had to do when you counted negative? You go clockwise, right, instead of counterclockwise. You're going to count clockwise, remember? Watch. Clockwise is this direction. So 0, yes it is. Negative 90, negative 180. Where's negative 125? Quadrant 3. Mark it. It's negative, guys, so you have to count clockwise, which is backwards, isn't it? Normally clockwise is positive and counterclockwise is negative. It's just backwards, you just have to memorize it. Okay, your reference angle is right here. So to find it, and at 125 I'm trying to close the gap at 180. So 180 minus 125. What's my reference angle? Good. It's positive.
It's positive.
Mm-hmm. Guys, all the negative does is tell me which direction to go. Okay, one last negative. How about negative 100? Give it a try. Negative 100. Where's your reference angle? It touches X. So I'm from 90 to 180. Oh, I'm sorry, that's 100. 100 to 80 is how much? 80. Okay, does that make sense how to find a reference angle? Is everybody good with that? Then let's move on. Find the 6 trig values. This terminal side, in other words, the end. Passes through point P. Those are your directions. Let me ask you a question. If you were going to plot negative 5, negative 12 on a coordinate grid, what quadrant would you be in? 3. And that's what we're doing here, okay? We're just going to plot that point. So do me a favor, and it doesn't have to be exact, okay? If you have a coordinate grid here for a second, and you're in negative, negative, we're way down here somewhere. Do you agree with me? Now, on the unit circle, watch for a second. If I'm on a unit circle, let's say I'm at this point right here. Negative root 3 over 2, negative 1/2. Remember, we went out and over. So in other words, to get there, this is the x value, which matches root 3 over 2. And down matches the y value, which is negative 1/2. Right? Okay, so to get to this point, I had to go left and down. I went left root 3 over 2 and down 1/2. Remember studying the unit circle? Okay, so this particular one, negative 5, negative 12, is not on the unit circle, because on the unit circle, what's the farthest we go out? Right, we go out as 1. But the idea is going to work exactly the same. Okay, the concept's the same. So if we're going to build this triangle for SOHCAHTOA, because we use SOHCAHTOA to find the missing sides, right? Find the 6 trig functions. So we're going to go out to our point. There we are. I know my ordered pair is -5, -12. Let's label it then. Okay? This is called the hypotenuse. Right? It's the radius earlier. So to get to -5 and 12, we had to go left -5. Then what do we have to do? We went down -12. And there's your right triangle. Build your triangle, left and down. Okay, and what confuses kids on this is now I need this measurement right here. This is called the hypotenuse. And this is what gets confusing. Your hypotenuse is always positive no matter what. And the reason is because it's considered to be a distance, right? In regards to a point, I'm going to go left 12 and down 5. So there's my negatives. But when you find the hypotenuse, your hypotenuse is always positive because it just counts as distance. Think about absolute value. In other words, how far am I from this dot to the center? Okay? That's all it is. Right? So we need to find the hypotenuse. We have 2 legs. Remember the formula? Now, if you got a calculator, you have to be careful. Because every time you square a negative, what's it going to turn? Positive. And if you don't put parentheses around it in your calculator, you might as well just stop. You're going to miss the problem. You either A, need to realize 5 squared is 25 and write 25. Or if you're going to type in your calculator, you have to have parentheses around it. Whichever one you choose. So plus -12 squared equals C squared. So 25 plus 144 is C squared. 169 is C squared, so C is 13. I'm going to give you a little trick here. When you write down your hypotenuse, if you will circle it, because you use it a lot, it will make life better. What's inside that circle is always the hypotenuse, and it should always be positive. Okay, now, let's find SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the 6 trig functions, let's start with sine. Sine of theta. Guys, I don't know. I don't know what theta is, so we're just going to call it theta. I'm talking about this angle right here. What is sine of that angle? Well, how do we find sine? If I'm on my unit circle, sine is x, but we aren't on the unit circle. Sine is opposite over hypotenuse. Look at your picture. This is my angle. Opposite is right here, isn't it? And adjacent, guys, is always x. Okay, so I want opposite over hypotenuse. So what do I want? -12 over 13. Now go to cosine. Cosine is adjacent. The adjacent of the yellow angle is the -5. Adjacent is x. So -5 over 13. Now let's move to tangent. Tangent is opposite over adjacent. What's opposite? -12. What's adjacent? -5. So -12 over -5 makes positive 12ths. So there was your 3 trig functions. Let's find the other 3. They're very easy. I've already done all the work. Now all you gotta do is do what to them? Flip them. Okay. There's equal signs cosecant. Starts with an S, that's going to start with a C. Cosecant of theta. Now flip it. 13 over 12. Now, kids get confused about the negative. You can put the negative with the 13. You can put the negative with the 12, or you can put it out front. It doesn't matter. If sine is negative, its flip is also negative. Where you put the negative doesn't matter. Flip of cosine is secant. Guys, stop talking. You're distracting me and myself. Take notes. That's what we're doing right now. Flip 5 over 13 to be 13 over 5. It doesn't matter what the negative goes. Yeah. Now tangent is cotangent. 5 over 12. Once you have the first 3, the other 3 are nothing. Right? -2, 7. point, -2, 7. Remember, this is the x value, this is the y value. Cosine and sine. All right. What quadrant is that?
2.
Okay. Here's my advice to you, my help. We're going to go left, so I'm going to label that, -2. But then we're going to go up, so I don't want that inside my triangle, so I'm going to put it down. Then we're going to go up 7. There we are. All right, where do I always come back to? Where are all the right angles from in the origin? So there it is. Make sense? Let's find the hypotenuse at both legs, so you're going to add. Be careful. Put your negative in parentheses. At both legs, so that's easy. So 4 plus 49. It's not very pretty, guys. So C is just the square root of 53. Is there a perfect square that fits in 53? No. So it's just 53. I would put a circle around the hypotenuse. So the hypotenuse is square root of 53. Now find your 6 trig functions. So we took sine. Do you remember what sine is? Opposite, right? Okay, what's opposite of the yellow angle? The yellow angle. What's opposite? Remember, adjacent is always the x. Because our reference angle, right, always touches the x-axis. So sine would be, what did we get, guys? I can't remember. 7 over root 53. You can't leave that there. Okay, you may be able to do this in your head. If you can't, that's all right, but I know that I have to multiply both of these by root 53. Which means I'm going to have 7 root 53 over, no, because what happens? They cancel, so you just get 53. Because if you do square root of 53, like, think about it. What's the square root of 2 times the square root of 2? The square root of 4, which is 2. It undoes itself. Now cosine. Adjacent over hypotenuse. Adjacent is the x. Now, you'll get really good at this to where you can just now look at the answer and say, okay, -2 root 53 over 53. If you can do that, by all means, go ahead. You don't have to show the work like I did on sine. Tangent to the last one. Opposite over adjacent. Adjacent is always x. So 7 over -2. Now we go through reciprocal functions.
Oh, you couldn't have a negative
You can have a radical. Okay. Now, the flip of sine is cosecant. Okay, stop for a second. What's easier to flip? The circle, we're talking about sine here, the circle in red or the circle in blue? Yeah, red, because the red puts root 53 on top and you're just done. You don't have to do any more work. So flip the one that's the easiest. It doesn't matter, they're the same thing. So flip them. Flip all 3. Which on this part you're going to get root 53 over 7. Cosine is secant. I'm going to get root 53 over 2, but it's negative. The whole fraction is negative. You put the bottom, top, it doesn't matter where. And then tangent is -2/7. What do you think? Easy enough? What are we going to be careful of? Yeah.
You get cotangent from the bottom one?
Yes. It should be cotangent. Thank you for that. you to be careful of. Yeah, you gotta be careful. Don't leave radicals on the bottom and watch your signs, okay? That's where you're gonna mess up. There's actually a little saying that you can use, and I'll bring this up again, but it's all students take calculus. There we go. Okay? And here, everything is positive in quadrant 1. Sines are positive in quadrant 2, right? What do you think is positive here? Tangents here and cosines are positive here. It tells you what's positive when. So if you'll notice, what quadrant was I in? 2? Right, so only sine is positive. And look at our answers. Sine was positive, the other 2 were negative. You see it? It's a way to check. Does that make sense? Let me show you again. The little thing is all students take calculus. So everything's positive in quadrant 1. But I wasn't. I was in quadrant 2. So only sine is positive. Look at my answers. Sine is positive and the others are negative. All students take calculus. Sine is positive, tangent is positive, cosine is positive. It's a good way to check your work. All right, get your unit circles out. Find the exact values of the 6 trig functions. Let me ask you a question. Is 225 on your unit circle?
Yep.
Yep, it is an angle on your unit circle. Alright, the next question then. If it's on your unit circle, what is your hypotenuse always on the unit circle? 1, remember? So when you're looking for sine of something, okay, let's just think, there's a little think bubble for a second. If I'm talking about sine of an angle, it's opposite over hypotenuse. When I'm talking about cosine, it's adjacent over hypotenuse. But what is the hypotenuse always going to be? The hypotenuse was always what? In the unit circle. The hypotenuse was always 1. So what cool thing we figured out then is that if your sine, it's just the opposite, and if your cosine is just adjacent, because dividing by 1 didn't change your answer, does it? Well, adjacent, remember we always decided is the x value, right? And your opposite is always the y value. So if you look at your unit circle and find 225, I'm right here. Is there a point that matches? 225 is 5 pi over 4 radians, and there's a point. You see it? Okay? The point is root 2 over 2 negative, and negative root 2 over 2. And just by looking at it, I can find sine, cosine, and tangent, can't I? Because what's the hypotenuse? 1. So what did we decide? This is the x and the y. Right, and let's look over here. Okay, the x is the same as the adjacent, so it's considered to be the cosine, and the y is the opposite, so it's considered to be the sine. Isn't that cool? You didn't have to do any work. If you're on the unit circle and you know the ordered pair, you know the sine and cosine. Because you're dividing by 1. Your hypotenuse is 1, so there's no reason to divide. So if you're going to find the 6 trig functions, let's find them. Sine of theta is the y value, so negative root 2 over 2. Cosine of theta is the same. And tangent, alright, it doesn't give me tangent. But tangent is opposite over adjacent, right? Or y over x. Tangent is the same thing as y over x. So if you have negative root 2 over 2, or negative root 2 over 2, what's it going to give me? What's the exact same numbers divided by each other? What do you get? 1. Okay, I want to ask you a question. Use my little trick that I just gave you. All students take calculus, and let's check and see if we are correct. What quadrant are we in with 2 negatives? Quadrant 3. So only what should be positive? Tangent. Negative, negative, positive. Does that make sense? Okay. It's just a way to check. Is this find the 6 trig functions? We just found 3. It's okay. Just for time. Let's move on to the next one. This is the last one. Last problem of your notes. What is it? Is 60 on your unit circle?
Yeah.
Okay. The reason I know it's on your circle is to find the exact trig functions. So if 60 is on the unit circle, is negative 60 on the unit circle?
Yeah.
Yeah, you just count what? Y'all remember how to find it?
Yeah.
You count clockwise. So you ready? Wide is 30, so negative 30, negative 45, negative 60. So it's the same spot as what? 300. Do we have an ordered pair there? What is the ordered pair? 1/2 negative root 3 over 2. So let's write down the ordered pair. Because my hypotenuse is 1, dividing isn't going to help any. Right? Adjacent is the x. Right? Opposite is the y. This is x and y. Adjacent is the x. It's cosine. This is sine. So cosine of theta is just 1/2. What's sine of theta? Sine's what? Negative root 3 over 2. Good. Now be careful about tangent. This one's harder. I'll give you something to try. Tangent's y over x, right? Opposite over adjacent. Opposite is the y, adjacent is the x. How do you divide complex functions? Do you remember what to do? Change division to have negative root 3 over 2, right? Y over x. I'm going to change division to times. Do you remember that doing that? Change division to times and flip this. So it becomes 2 over 1. So multiply straight across. Inside numbers stay inside the radical. Outside stay outside. So negative 2 root 3 over 2. The 2's cancel. So tangent of theta is negative root 3. Let's check our little trick. All students take calculus. I'm in quadrant 4, so only cosine should be positive. Yes, these are negative, so I'm right. Right, does that make sense?